Good morning, good afternoon, everybody, and welcome to the MODSIM community and our final episode in the 3D Experience MODSIM series. This episode is called MBSE Integrates a System Model and Simulation, New Capabilities in the OEM Applications in Aerospace and Defense. Next slide. This series aims to provide you with a better understanding of how integrating design and simulation can truly benefit you and your business. If you've missed any of our earlier episodes, then the replays are available to view on our community, so be sure to give them a watch. I'd like to invite you all to ask any questions to our presenters today in the comments section, and we'll answer them at the end of the session. Next slide. We have three presenters today. Our first presenter is Chris. Chris is a CATIA MBSE Senior Architect. He has 20 years of experience in the A&D industry and healthcare industries across a full spectrum of product development lifecycle, with a focus on systems architecture and engineering. Our second presenter today is Salius. Salius is also an MBSE transformation leader and a senior consultant. And I've lost the slide. Thank you very much. He has 18 years of experience at Dassault Systèmes in model-based system solutions and at the core of the R&D team. Our third presenter is Dave. Dave is a familiar industry process consultant expert, and he has 20 years of experience working with customers in A&D, high-tech, and oil and gas industries, focusing on process integration and multidisciplinary design optimization. Today's agenda is as follows. We will start with Chris, who's going to give an OEM perspective update. We will then move to Dave, who's going to give an overview of the process composer. And then we're going to move to Dave and Salius, and where they'll be talking and giving a demonstration on the extended simulation to camo. And then Salius will wrap us up with a discussion piece on the new capabilities. And finally, we'll conclude with a Q&A. So I'm now going to hand over to Chris to begin. Thank you very much, Chris.
Thank you very much, Jessica. So I'd like to share an OEM perspective with you here this morning and walk you through some recent history of MBSE and simulation as implemented at one particular OEM. In the past few years, the U.S. Department of Defense has been strongly encouraging their suppliers to leverage a digital engineering strategy for product development. So one of the significant advantages of this approach is illustrated here in this slide from 2016. And this is from the Air Force Research Laboratory Multidisciplinary Science and Technology Center, or we'll just call it MSTC. So conventional product development really relies heavily on physical prototypes, first articles, and production vehicles to develop confidence in system performance and reliability. But this incurs significant cost and delay to address problems because they have to be fixed in vehicles that have already been designed, released, and manufactured. However, modern tools for multidisciplinary analysis and optimization can really enable design teams to assess performance, discover potential defects, and really build greater confidence much earlier in the process using digital models and simulation. So the Air Force Research Laboratory and the MSTC within the research laboratory indicates on this slide that this approach really can shift the confidence curve to the left, realizing gains for all stakeholders. The 3D Experience platform and Cameo Systems Modeling provide an integrated digital environment that enables this shift of the confidence curve by providing really a single environment for modeling and simulation. Of course, OEMs need to reduce risk and cost while constantly improving product capability and quality. So here we'll show you the details of how this is implemented at major OEMs and specifically at Lockheed Martin. So there's two milestone projects that I think is really helpful to go through a bit of history to get to where we are today, so you can understand how OEMs have utilized and are utilizing these really important technologies for MBSE and simulation. So in April of 2017, the MSTC issued a broad area announcement for a program called Expedite. And this Expedite program was to focus on the advancement of multidisciplinary optimization technologies in a lot of different domains, state-based modeling, effectiveness-based design, path dependency, transient operation of systems and subsystems, uncertainty quantification, high performance computing, cost, and reliability. So it covered a lot of ground. And in July of that year, Lockheed Martin Aeronautics Advanced Development Programs, or ADP, was selected as the winner of the competition to execute on this effort to shift the confidence curve. And during the first portion of the Expedite program, Lockheed Martin ran a concurrent internal research and development project to evaluate Dassault Systèmes' 3D experience platform as applied to Expedite. So this project utilized the 3D experience process composer, identified here as Process Explorer, really as a central integrating function for analysis and optimization. Now, we'll get into the details of Process Composer in a few minutes. Dave is going to take us through that. But for the purposes of this history and describing these projects, what you need to know is that Process Composer enabled the project Expedite and Lockheed Martin's rapid conceptual design team to bring together a lot of different modeling and simulation tools to efficiently develop design spaces across a broad set of system parameters. And so what you see here is a marked up Process Composer workflow that includes parametric vehicle geometry in CATIA V5, and that's tied into Lockheed Martin proprietary tools for aerodynamic simulation, engine simulation, mass analysis, and mission performance. And so the 3D Experience platform enabled the team on Project Expedite to apply multiple optimization algorithms across a high-performance computing system and enabled them to explore the resulting design spaces effectively with results analytics post-processing. So there's a link at the bottom of the page here where you can learn more about this Project Expedite, this first step in recent history for bringing together MBSE and simulation. So the second step, having successfully implemented 3D Experience Process Composer for multidisciplinary analysis and optimization on Expedite, Lockheed Martin took it to the next level, and they asked Dassault how model-based systems engineering, or MBSE, in Cameo could be integrated into their rapid conceptual design process. And we said, that is an excellent question. So the conventional perspective of MBSE is illustrated here in this slide from NavAir, which originated from Sandy Friedenthal, one of the founding fathers of the MBSE systems modeling language, or SysML, as referenced here. In this perspective, the system model that you see here in the center of the diagram, it really just lives in Cameo, in SysML. It's separate from analysis and simulation, which is represented in the gray box to the right. So in this framework, any analysis and simulation needs have to be somehow ported out of the system model into other tools. And then the results have to be ported back into the system model. And so we said to Lockheed Martin, you're right, there is a better way. So we use 3D experience to extend the boundary of the system model, integrating the architecture within Cameo and Teamwork Cloud with CATIA spatial and structural models, and using Process Composer to tie in native simulation tools, as well as the Lockheed Martin proprietary tools that were used in Expedite. In this arrangement, any simulation in Cameo can instantiate a simulation experience in Process Composer, pass parameters to it, and have the parameters returned into the running Cameo simulation. This was an important step forward in the ability to perform high-fidelity modeling and simulation in multiple domains in an integrated digital environment. And you can see a more detailed view of the resulting workflow from this project. You see the authoritative source of truth defined as the blue box. It contains Cameo, Teamwork Cloud on the left, and 3D Experience on the right, connected through requirements and Process Composer. And so if you want to learn more about this project, you see the link at the bottom of the screen. You can see a presentation on that work from last year. So now we come to our current state in 2021. The Lockheed Martin and other OEMs are now leveraging these critical capabilities in MBSE and simulation in new ways and with broader tool sets. They're connecting Cameo through Process Composer to additional simulation tools native in 3D experience, such as CFD, structural analysis, multi-body dynamics, and CST EMAG. And they're beginning to take advantage of a vastly improved drag and drop integration between Cameo and Process Composer. For example, shown here, an object in MBSE in the Cameo model can pass updated geometric parameters to the CATIA model and have it change directly. And another Cameo object can receive updates on the engine performance. So you'll see this and more demonstrated shortly. But first, I think it's really important for you to have a view on what really ties all this together. Process Composer in 3D experience. So at this point, I'd like to hand it over to Dave, and Dave is going to take us through more details on what Process Composer is and how it works.
Okay, thank you, Chris. My name is Dave Naring. I've been working with Process Composer and its forerunner for, as we said before, about 20 years. So I'm going to give you a little background on Process Composer. And really, Process Composer is one of several applications on the 3D Experience platform that we call the Process Apps. We're going to really focus on Process Composer today, but there's really a suite of tools. Simulation Companion is an application that allows you to bring data management to the simulation world and manage the types of ad hoc simulations that engineers and scientists do all the time. Process Composer is for orchestrated workflows that are well defined that you want to automate and run through the platform. And Process Studio is a tool that we can use to bring custom front ends to the simulation processes that you generate in Process Composer so that non-expert users, people who aren't necessarily analysis experts, can make use of the simulation tools that you create in Process Composer. Performance Study is a tool that allows you to evaluate different designs and try different values. And then when you execute Process Composer through tools like design of experiments and optimization, you're going to generate a lot of data. And in order to analyze that data, we have a tool called Results Analytics that allows you to sort through many design alternatives and come up with the best alternative for your given scenarios. All this is done on the 3D Experience platform, making use of something called 3D Orchestrate Services, which allows you to execute your simulations on the compute resources that are available, so that you can, instead of running everything on a local machine, you can make use of whatever compute resources are available. All right. So Process Composer is a tool that works with a very simple drag and drop authoring interface that allows you to bring in different components or activities into the workflow, and then drop some adapters within each activity in order to perform some sort of simulation. So you can combine multiple simulation tools into your workflow. That workflow can consist of single steps or parallel conditional branching of tools. And also, you can configure Process Composer to manage all of the input and output content associated with each tools. Things like the parameters that are required for each tool to execute, any files or data that is required at runtime, and any 3D Experience platform content that may be required as well. So you can really automate your simulation process through Process Composer by use of adapters. So this large blue box is called an activity, and within the activity, you use different adapters to perform different functions. There's many adapters available on the platform that allow you to interact with whatever simulation tools you want to interact with. So there are generic adapters, which allow you to launch third-party applications, work with external tools. These are adapters that do very generic functions like execute a command, manipulate data in a file, do calculations, or run some scripts. Some additional adapters are created to work with tools that exist on the platform. So if you want to change parameters associated with a geometric CATIA model, for instance, you would use one of these platform adapters. We have an adapter that works with the different simulation tools that are native to the platform. We have some native finite element analysis and CFD tools that can be executed using the simulation adapter. And also, if you have a Dymola behavior model, you can exercise that using the utility adapters. And last, we have some predefined adapters that work with third-party tools. So there's a MATLAB adapter that works with MATLAB programs. Excel is a very commonly used tool for doing some calculations and tracking some information. So we have an adapter that works directly with Excel as well. And we have one that works with Abacus, which is a finite element tool that Dassault provides as well. So Abacus doesn't exist on the platform, but we have an adapter that allows you to work directly with that. These adapters in your simulation workflow can be grouped together, and you can set it up for either local execution on your own machine or remote execution, making use of whatever compute resources are available to you. So basically, if you're going to create a workflow, regardless of whether you're working with tools that exist on the platform, external to the platform, really the only difference is which adapters do I use to work with that. So here we have a particular workflow that has 3 separate calculations. In the first one, we're using some internal adapters to change the winglet geometry associated with this particular part and do some meshing directly on the platform. So we're using some platform-based adapters. In the second activity, we're taking that same winglet geometry and we're working with a third-party tool, in this case, the Abacus program, to do a finite element analysis on that particular wing. And then in the last case, we're taking the same geometry, exporting it to a file, and running a homegrown commercial CFD tool, a homegrown custom CFD tool to work on the geometry associated with it. So the same different geometry is being accessed either by tools on the platform or external to the platform. And it's just, again, it's just a matter of which adapters do you use in order to automate this process. So the goal with Process Composer is to create what we call a simulation experience. And what is a simulation experience? Well, simulation experience is a simulation process that you build in Process Composer that's defined to have a certain number of inputs. And it's going to, when you execute that simulation process, you're going to generate some outputs. So you can think of it as a black box. And what that black box consists of is a fully configured simulation process with inputs and outputs. Now, how can I make use of this experience? Well, once I create a simulation experience on the platform, I can do some individual tests, try some different parametric values, see how that affects the overall design. I can deploy it to non-expert users with a custom UI. So if I have, I may be an analysis expert, but I have some engineers who need to make use of something I've created. So I can create a very simplified front end to this particular process. They don't have to know anything about Process Composer or the simulation tools that they're executing. They just need to provide the input values that they want to study, and the simulation experience will then execute and give them the outputs associated with it. And lastly, what we're going to focus on today is that you can execute a simulation experience directly from Cameo as a behavior. And so your Cameo model will have some sort of a block associated with executing something. And from an activity diagram or parametric diagram, you can configure Cameo to connect to the platform, send the input parameters that are required for the simulation experience. The platform will then execute the simulation experience, compute the results, and send those outputs back to Cameo. So this allows us to really extend Cameo's simulation capability from simple calculations and lookup tables to higher fidelity simulations. Whatever we can do in Process Composer, we can now access from Cameo. So the process that we're going to show you in a video demo in a few seconds basically consists of this. We start with Process Composer, and we create a simulation workflow or simulation process in Process Composer that does some calculations that are required. We can then drag that simulation experience into Cameo, and Cameo can then use that to launch the simulation through an opaque behavior in the parametric diagram. So when Cameo goes through this using Simulation Toolkit to do some calculations based on some parametric values, it's going to connect to the platform, execute the simulation experience, and get those results. So the next thing we're going to show is a little video demonstration of how we're using these simulation experiences to do a calculation within Cameo. So here's a Cameo model. And within this model, I'm going to analyze the range of a particular aircraft. In order to analyze the range, I actually have to do several different calculations. I need to change the geometry of the aircraft based on some parametric values, and then I need to compute the aerodynamic coefficients and compute some things associated with the engine, and then also compute the range. So at this point, we're setting up some parametric values, and then in the diagram, we're going to create a parametric diagram, and we're going to bring in a simulation experience from the platform. And so here we're in a browser. We're just searching for simulation experiences that may be available on this particular server. And there are 4, and we need all 4 of these in order to do the calculation. So we're going to drag the first one into the Cameo model. And then you'll see the inputs and outputs are already there on the simulation experience because that was configured by Process Composer. And now Cameo is just setting up links to connect those parameters within the model. Now, in order to compute the range, there are, like I said, there are 4 separate calculations that need to be done. So we're dragging in these next calculations as well, and we're going to then hook up each of these into a parametric diagram. So all of the parameter values are going to be automatically connected using the Cameo capabilities to map these parameters. So here we've built this particular workflow. So, so this is an activity diagram with the parameter flows defined, and you'll see that we have four separate simulations that we need to execute on the platform. The goal is, I screwed up here. Let me get back to that part of the video here. Okay, so so the goal is to have a range that exceeds 1,000 kilometers. So at this point, the calculation of the range hasn't happened, so it's showing in red because we haven't satisfied that requirement of making it fly 1,000. So we're going to execute the simulation, and you'll see we start with the parameters being sent through Cameo. And the first interaction that we're doing is we're connecting to the platform to execute an update to the CATIA model. And then almost immediately, because it doesn't have to happen before it, we're also sending some parameters down to the second one. I'll talk about that in a second. But actually, the second and third are all getting their parameters loaded up. So the first connection is updating a CATIA model. So you see that we've changed the shape of the wings. The second calculation is to do a fluid analysis. And then the third is to do an engine analysis so we can compute the thrusts and weights of things associated with the engine. Finally, once all three of those are done, Cameo sends the values that are calculated off to an Excel spreadsheet that computes the range of the aircraft, and then that range comes back to Cameo. And at this point, we see with that design change, we have a range now of 1,100, which satisfies the requirements. So this is showing how we're making use of multiple simulation experiences to compute something directly from the Cameo environment. Now, here we're showing the platform where we can actually view some of these results. We've got some widgets associated with the 3D Experience platform, so you can evaluate these different design alternatives. You'll see in the lower right, we have the two different geometries superimposed on one another. So you can see one is in blue, the other's in orange. You can see sort of the differences of the shapes. We have access to the parameter values associated with each design on the left. And in viewing this particular, you can see these combinations. You can see them overlapped over one another, and we're gonna go through and do some cutting planes to see where the differences are throughout the aircraft. So these visualization tools are there on the platform to allow you to evaluate these design changes. All right. So the whole point to this is that, as Chris was saying before, we want to try and move the confidence curve further to the left. And to do that, we need to bring the simulations much earlier in the design process. And the 3D Experience platform, working in conjunction with Cameo, allows us to do that. So while Cameo has always been very good at doing some simulations or calculations using principal equations or lookup tables, by bringing in the 3D Experience platform and simulation experiences, we can extend that capability to allow you to do higher fidelity simulations. So that actually brings in a lot more simulation earlier in the process. And the simulation experiences that you have on the platform bring with them everything that the platform provides. Things like they're life cycle controlled. We provide secure access to these simulation experiences. It resides in a single source of truth, and you can execute them anywhere. The 3D Experience platform maintains your design, project, and requirements traceability as well. And so now, instead of using just Cameo and your system architecture model in the concept stage, you can extend that to preliminary, the preliminary design stage as well as the detailed design stage by making use of these higher fidelity simulations. So at this point, we can move to roadmap of what Cameo is going to be doing in the future, and I'll hand it over to Salias.
Oh, thank you, Dave, and thank you, Chris, for great presentations. Talking about the roadmap, as you can see here, this line shows current state, right? We already have this capability, as Dave presented, to take simulation experiences and link to system model. So we can use this universal interface between the models which are wrapped by workflows with Process Composer. So this capability works. You can request this Process Composer integration, which is provided based on request. So if you have 2021X installed on your company, you can just request that. And then Refresh 1, which was released in June, just a couple of weeks ago, has some enhancements on the simulation side of the Cameo model. So the simulation now runs also on the server. Also, this capability is based on request because it is still in development at some stage. And why is that needed? Because we want to enable Cameo as a connector for the Process Composer. So a bit different type of integration, right? So the Process Composer will be able to run Cameo from the server side directly. And I will show one video, that already you can simulate, Cameo models on the server, because this is first thing to do, and also you can run Cameo models through command line, which is parameterized command line. So that means that you don't need to load the file or kind of save results in the file you get as the parameters, command line, to run the Cameo model. And that's very fast. Also, server-side simulation is much faster than standard client-based because you don't need to load the models. They are already loaded. You just, run them on the server. So what will happen in Refresh 2 in 2021X, December 2021? So we'll have a multi-thread server-side command line capability. So then it will be possible to say that okay, you can use it, with multiple projects. You can run the same project multiple times at the same time. Or, for example, the more common case is that many users are running, this simulations, right? So this is still in progress to develop this part, right? And this is technology, again, to prepare, for the connector for Process Composer, for Cameo connector for Process Composer, which out of the box should be available in 2021X release, commercially available, which is mid-2022. And it will enable trade studies, design of experiments, and other things what is already available with Process Composer, but Cameo was never connected there before. So, and again, just to emphasize that this is to enable Cameo as a connector for Process Composer, but Cameo already can take simulation experiences from Process Composer, any of them, and use them in activities and parametric diagram. That works already. So here we see this Refresh 1 architecture, which is current, when we see the server-side simulation, which is, moving Cameo simulation toolkit to the server side. It's not like removing completely from the client side. Nothing will change on the client side, and still we'll have simulation as rich client for Cameo, but server side will be lightweight, at least at the beginning, and will be fast, and it is already available, right? So you can run from the Cameo collaborator, you can run from command line, you can run, for example, for Python, Jupyter notebook. I will show a quick demo on that. And here we see Refresh 2 when we have Docker, and we can run multiple instances pretty much on the server side, and that will enable the connector. And the connector commercial availability 2022. And here we see a short video. So this is a Cameo collaborator for Teamwork Cloud. You can see that we can edit on web, run the simulation on web, from Cameo collaborator. And here we see from the Anaconda Jupyter Labs, we can execute command line server-side simulation of the pretty much any model, on the Teamwork Cloud, just connect. And that works already with Refresh 1 and Refresh 2 will have multiple instances. So thank you very much.
I'm going to go ahead and show a couple more slides since we have a little bit of time. And so in my discussions of Process Composer, for the particular demonstration we did, we were just running Process Composer to compute a single data point using the tools that were there. But Process Composer can be extended to do design studies and optimization. So when you build a simulation process, you can create an automated process. And once you automate that process, you can employ different design exploration techniques. So we have what's called an exploratory hierarchical process. So we have a lot of different tools that allow you to do things like trade studies using design of experiments. So if I were to run a trade study of that particular aircraft design, I could run multiple versions of the design of experiments and come up with a representative range for several different aircrafts, and I can automate that process as well. Also, another technique that we have built in to Process Composer is optimization. So you can improve your design and try and meet requirements that way by giving ranges of the inputs that you're willing to vary in order to try and achieve some goals in optimization. And then also a Monte Carlo simulation can be used to account for variability in your design. So you can take into account things like the part-to-part variation or uncertainty in your loads and boundary conditions, and you can do fully probabilistic or stochastic analysis as well. So all of that capability is built into Process Composer as well. And earlier, Chris talked about the Lockheed Martin Expedite workflow, and their workflow in Process Composer was actually done to do a very large design of experiments. So they actually ran about 10,000 points, and this particular Process Composer workflow was broken up into several activities that did very specific things. So there was an activity that updated their CATIA V5 geometry using a series of our generic adapters. And so they would change the wing shape and the areas and aspect ratios, sweeps, etc. There was another activity that did some that computed all the mass properties using Excel spreadsheets and worked with the information that gathered from the CATIA model as well. There was a tool that used an activity that used their internally developed propulsion simulation capabilities to compute some values associated with propulsion. They used some aerodynamic tools as well to compute some of that. And then a mission performance was also put into the workflow. So in this case, they ran a very large design of experiments. So they didn't just run this through one design point or two. They ran about 10,000 points and then used this to evaluate a lot of different things. So all of that capability is also available in Process Composer. So that's, at this point, that's all I have. Do we have any questions?
Hi, David. Yes, we do. Thank you very much.
Okay.
I'm just going to bring everybody back in.
Mm-hmm.
Hi there. So we've got 2 questions so far. And to everybody watching, please feel free to keep them coming. Just ask them on the comment section. So the first question is, can an activity diagram model of your business process be dragged into 3DX to create a Process Composer model?
That's a really good question. As of now, no, that capability is not there. There are ways to take Cameo models and export them to the platform for using other methodologies, but not into Process Composer, because typically Process Composer is configuring how to do simulations with whatever simulation tools you have, and that's not typically what's done in the Cameo model. I have worked with people, with customers who have exported a Cameo model into the platform to bring in together like a series of components that work up an entire system that are connected using a logical and basically a logical Dymola model is created on the platform from a Cameo model, but no, not from an activity diagram to Process Composer. That's not something that exists at this point.
Okay. So the next question is quite a long one, so bear with me. So excellent demonstration. However, is it safe to assume that this capability not only applies to the no magic products, i.e. Cameo Systems Modeler, but also possible for CATIA Magic solutions? I'm interested in whether this will be available for Magic Cyber Systems Engineer and Magic Systems Architect products.
Yes, absolutely. So this applies also for all other products like UAF products and both portfolios, CATIA Magic and Cameo, and also UML, because the simulation is based on UML, and pretty much there is no constraints that you would need SysML to execute this integration and link of the models. So yes.
Okay. We have another one. What is the back-end development for Process Composer, like CAAEKL for CATIA?
Let's see. I'm sorry, could you repeat that?
Sure, let me post it to you.
I was going to say, could we, yeah.
Yeah, there we go.
Okay, so Process Composer uses different scripting languages. We have the platform itself has a scripting language called 3DX script, which is based predominantly on Visual Basic, but you also can use a lot of different scripting languages within Process Composer. There is a scripting adapter that works with Jython and Dynamic Java. So I hope that answers the question. Yeah, I would say the main scripting languages would be Jython.
Thank you. Just refreshing to see if there are any more questions that have come in. It doesn't look like it. Okay. Just check there. So we should end there then. I just want to say thank you for our presenters. It's been a really interesting session. And just before we close, I'd like to remind everybody that this was the final episode in our MODSIM series. So all of the replays, including this one, will be available on the community, on the MODSIM community. And we encourage everybody to go back and watch the previous episodes. Many thanks to our presenters again, and to you, to our audience, for joining us for the entire series. And we hope to see you at an event very soon. Thank you very much, everybody.
Thank you.
Thank you, everybody.
Thanks, everyone.